Hello, everyone, and welcome to the broadcast. We're going to be doing some coding today. Hopefully, we're going to see some results from all of the research I had been doing, all of the testing I had been doing during some of the downtime we had. But before we do, let's check in with kitties. We do have Ember across from the keyboard. And we have Sky, Mason, and Sherbet on the bed. I finally found a configuration of the pillows that seems to get all of them on camera at once. Sammy is, or at least Sammy traversed the cat bridge. I don't know where she ended up. But yeah. Here, let me show you where we are. So this is my test project. So you can see it's sitting at 30 frames per second visual update, and then I have a physics frames per second. It's an approximation, but the physics, the actual calculation of the movement, is running in its own thread. This is not just the Godot physics call running in its own thread. This is the updating of the entities. When the physics tick comes around, it jobs it off to another thread, or it hands off to another thread. So let's watch what happens. It's going to scale up to 10,000 objects. Oh, hey there, L Gamer, and thank you. So here we go. These aren't animated objects, they're just sliding Godot icons. Now we should see the physics frames per second. Oh wow, it did pretty well that time. So that was 10,000 objects doing one movement calculation, converging on the center. Held pretty steady at right about maximum physics frames per second. You can see the icons are starting to reach their outer circle. We are going to see, you can see some distortion as they spiral back out a little bit, but ultimately works. So then, if we go in, and what we're going to do, we're going to show you the difference. It's not entity manager, it's the minimal entity. Now I'm going to have 5 movement calculations. Same calculation 5 times. Let it warm up. Now physics frames per second is going to drop here. So we're down at 20. So at 5, we're down to 15 physics frames a second. Oh, Gamer, if you're not familiar with the channel, we've been doing a game development project. This is day 71 as far as on-stream development. I've been doing testing on this particular program that we're seeing here. Been using it for testing for optimization of the game. So 10,000 objects, 5 movement calculations. We're getting 10 physics frames a second. And then this would be the worst case scenario as far as how we're proposing that the actual game goes. 10 movement calculations. 10,000 objects is too many, by the way, but this holds out with like 5,000, which is, while not 100% within reason, it's not out of the question. I really would like to hit that 10,000 if we keep the number of things that can be spawned at once multiplicative. So at about 3,500, we start the physics frames per second dropping. At about 10,000, we've lost 10, but we hit about 15 physics frames a second. This is not terrible, but you can see it does give us some choppy motion. looking at the way the performance is going, all of the cost is in the movement logic, is iterating over those movement functions. They are simple calculations ultimately. There's some distance calculation and similar, but that's really simple stuff when you think about it. The thing that's so the raw cost, so even if I reduce the complexity of the movement down to just move in a straight line to the center, we still get a tangible frames per second loss. So yeah. What we're going to be doing today, just check something real quick here. Yeah. What we're going to be doing today is we're going to be porting over the code that I had before our node-only experiment recently to use this physics thread model. But to do that, there's an extra step, and that's to get a kind of a master entity manager. Let's do a quick test and verify where we ended up. Look at our catalog, and our load items, and our homing mouse. What's the matter, Cindy? Sammy was prying at one of the toys before running forward and kind of giving it one little smack with a paw and then being done with it. Okay. So we're going to get a positioner. We're going to do, so that it doesn't choke out on that part of the processing, we're going to be positioner burst 1. Use 5360. Then we're going to look at our positioners here. And we'll just make that spawn 50 at once. Oh yeah, I need to turn the movement back on. Where did I put that? Entity. Pretty much, Tess. Pretty much. Clearly broke a thing. I think I know where it is. In physics process, we need to have the zone spawn. So you can see by about 900 things, our frames per second plummet. And by just about that 15 to 1700, we are down to like no frames. So yeah, we need to do better on that. So to get the thread model, the first thing I need to do is to have an entity management system, which needs to go above and beyond what we're doing with the pooling. Let's also, so pool minimum. We are going to, instead of appending it to the pool, we will always create one. Flip that over here. What this is going to do is never cache an entity. Hey there, Ice Drakes. Well, clearly we have a problem here. Just want to do the clone. So what we're going to do... Yeah, we don't want to do that. So never caching entities. Let's go into the rest of our caches. One of the things we found is that caching didn't seem to do anything. Rid of it. I have some ideas on how to do this better. Not the caching part, but just the, well, kind of the caching part. Hey there, Michael. Welcome, welcome. Folks, if you do notice that I seem to be talking to somebody you can't see in your chat, they're probably in one of the other two. I do have a Twitch stream and a second YouTube stream going. Different visual formats, different platform. Yeah, I finally got all three kind of cat napping spots there on camera at once, so we can fully see them. Well, almost. Need to make sure we aren't storing any of this stuff off. So what we're doing is we are entirely just creating the objects. No worries. Did you have a good holiday? Beverage. Make sure that we are not cooling anything. No pools. We'll come up with a different way to try to save time on this. Assuming we keep going with this model, I figured out a way to make the shapes less fragile as far as being in an area. But we've still got to wrangle that. And some of that comes from the experimentation that we did. essentially jobbing off a whole bunch of this stuff to different services within the code. Lines, shapes. Shape pool there. Use them if we need to. Add it to the pool. We are making a game, Michael. We are working on some performance optimization for it, and we're building up to a substantial change here. Move on it. Yes. Let's make sure it worked. Check and make sure we don't have any errors being generated. Okay. So we are at effectively ground zero. We removed the pooling. It didn't have any impact on the performance at this point. That's going to be later refinement after we get done with what we're about to do. What you doing, Sammy? So, how long has it taken us? This is day 71, Michael. I have been doing some pretty extensive testing off stream, more and more lately. But stream 71 so far to get to that point. Okay. So eventually we're going to be switching over to C or C# for some of this stuff for performance optimization. And to do that, we're going to have to load up... 1 second. Spiking audio there a bit, sorry. We're going to have to do a different... we're going to have to use the other executable. My microphone can't decide whether I need to do plus or minus 10 decibels during stream or not. Okay. So we've got an entity manager now. I get that with Sky sometimes, Michael. If he wants attention and or wants me to refill the food dish, he will sit right next to my mouse hand and he'll kind of roll around and grab at the mouse. All right. So what the entity manager is going to do is it's going to be the repository of all of the entity objects. Everything needs to go there when it's created, and everything needs to be removed from there when it's done. So we're still going to follow the same pooling logic to initially create them, but as soon as we do so, and when I mean pool, it's we're gonna hand it off. Actually, we won't even need to hand it off, because as far as creating the entity, these are the only two things that happen. Yeah. So we clone it, and then later we'll call initialize on it. All right, so let's... And one thing of note is that we do a lot of kind of seat of the pants here. If I were doing this a little more professionally, I would have design documents and whatnot ready to roll. But we don't. I think, but we're not, and I don't. Well, I appreciate that, Michael. Thank you very much. Okay, how we do? Interesting new syntax. Godot 4.3, as far as the auto functions, it's actually started noting returns void. So explicitly you're saying it does not return anything. And in that pattern, I could say return. Very C notation there. So nothing comes back. But common notation is pass. It's just a closing line here. Okay. So I can say add an entity and have it return. Hey there, Erebus. Welcome, welcome. But I think we'll create the entity elsewhere. We'll have the entity pool created for now. There's a bit of spaghetti forming here, but, you know. Given that, well, it's going to depend. If I have to use C# libraries, then I'm not sure which platforms it's going to be viable on. Using C libraries and similar constraints where you can launch it. I believe the C libraries can still be compiled for use on mobile, but not on web. And then we're going to have function. Array of entity objects, and by default it is like that. Hello, Sky. Hey. Sky can be a bit chatty. Are you going to sit with me? Make up your mind, because you can't stand there. Come on. Come on, you. Okay, so let's get the rest of here. So we have variable. This is the update thread. The body that you see before you, Michael, is about 3 or is it about 4 now, Tass? At least about 3. Let me do function underscore ready. Red.new. So what these objects are, the update thread is going to be the thing that runs kind of in a perpetual circle. About 3, okay. The mental engram that the body contains, that was consensually obtained from the head researcher of the Catbot factory, is much older than 3. So this, the update thread is the thing that we're going to be calling into in order to, or that we're going to be utilizing in order to update all of the entities. This is the thing that's going to say, okay, entities, all of you move. Everything that's in that collection there. We should actually have variable entities to remove. Array of entity, just like that. So this is what's going to be updating them. This is a gatekeeper for messing with the entities collection. So only one thread is allowed to touch the entities collection at a time. And the same is true for the toAdd array and toRemove array. So we have a toRemove and a toAdd mutex. We have these collections because they're pool locations. If I want to remove one, I add it to the remove collection until the physics tick comes around again. We remove them from the list, then we add things to the list, then we process the list. But one of the things that having the toAdd and the toRemove will allow us to do is reduce the amount of contention for the thread resources that you can get otherwise. Because if if I were to add directly to the entities collection, then every time it's trying to update the physics, it would have to hold the entities lock it has to hold the entities lock the whole time. So nothing can add to it or remove it. Only about half an hour, Benny boy. And welcome. All right, so then we're going to have... Oh, another fun thing I learned. Region. Default methods. Oop. Look at that. Bracket notation to lump all the functions together. Organized code. Oh, we need our semaphore. What the semaphore is for, is essentially a moment in the thread that it will wait until the semaphore says you can go through. It's another gatekeeper, but instead of it being an indicator that somebody has claimed access, it's kind of like a stoplight. I'll tell it's the thread will wait on it, and then the physics tick will tell it, okay, you can go now. So, semaphore is equal to semaphore.new. So then we have variable exit thread is equal. This will be the signal to tell us to bail out of the thread. Then we're going to have I don't want to have to need this, but for now, we need this. What accumulated delta will be is that until we're able to take a physics tick and apply it to the thread, until the thread is done processing, we are keeping these deltas. In saying, okay, 13 thousandths of a second have passed, but we're still doing the entity update. Accumulate that 13 thousandths, and if it comes around again, keep accumulating that until we can do another update of the physics. So here we are updating entities. This is the flag to tell us we're busy. What's the game gonna be about? It is a bullet heaven game akin to, in a similar vein of Vampire Survivors, with a particular weapon gimmick, how it's going to function. The theme of the game, the content of the game, is going to be based off of our backstory. So, while true for wait. So we get all the way done if we put, okay, yeah. If exit thread, then return. So what this is doing, this function will just run forever. It'll just keep spinning. At the start of the loop, it says wait for the semaphore. So until somebody calls semaphore.post, they use this variable and say post, this will sit right here. Once that post happens, it's going to check, should I leave? So the end the thread pattern is to set exit thread equal to true and then post. Do I know Demon Slayer? I know of the anime. I've only ever seen essentially the pilot episode. Episode 1. Seems okay. I generally don't go out of my way to follow shonen anime. It's not that they're bad, it's just I have to choose where I spend my time, and that's not my primary choice. So then we exit the thread. I only know the look of the main character and I guess their sister or something like that. That's it. So then we're going to say entities mutex dot lock. So this is where we're going to mess with the entities collection. We're going to loop over it. We're going to update it. This is a to add mutex. Hey there, Demo Frog. You know, I had never done threading until this research. In theory, I should be doing it this way. There we go. I'm now messing with the entities. Nobody else is allowed to mess with the entities. I'm now messing with the removal collection. Unlock. Nobody else is allowed to do that. Now the add collection. Nobody else is allowed to do that. Then I am done messing with the entities. Entity in as entity in entities to remove if entities to remove, it contains... It's going to be find. It's not the best. If we find it. No, we can do... we're going to do all of that here. Do all that here because the pool is not really doing anything anymore. All right, so for everything in the remove collection, we're going to see if it's in the main collection, just to be sure, because if we try to get rid of it and it's not there, problem. I don't like doing this. This is a n squared calculation because it's possible that everything to remove is at the end of the collection, and that would be bad. That is a lot of calculations. It's not really n squared. Actually, it would be more n. In theory, it's n, but if I were to call remove on every element, it would be n squared. Up to n squared. Yeah, computational complexity. Hey there, huge fan. We're getting there. We're getting there. You don't find it. And T. Okay, so we've removed everything it wants us to remove. We've added everything it wants us to add. Then add entities to remove dot clear. Removed everything, clear it out. We've added entities to add. We've added everything, clear that out. Or entity, which is an entity in entities. Forgot, we need this. This is the running tally. This is the one we're using. So now we're iterating over all of them and telling them to call their move function, which will in turn call each individual movement's move function. And get this far, we are updating entities. True. We can put it after the mutex. Okay, so this is our core loop. So we come in, we're ready to go, we're not exiting. We are beginning our update. We lock entities. We lock removal, and we go through and we remove anything in that collection. Then we lock addition, and we go through and essentially add anything in that collection. Then we iterate over all of them, tell them to update. Then we're done, and we loop back to the top. So here's our ready. Exit tree. This one's important. This is when we end the program. Don't think we need to we should just be able to purge them all from memory. It's possible that that will cause problems. We'll cross that bridge when we get there. Exit thread. True. Semaphore. Post. This says is when I am done with this object, when we are exiting code, we are going to tell it it's time to be done, run a loop. So here's physics process. We increase the delta. If not processing. What is it? Updating. Say current delta is equal to accumulated delta. Accumulated delta is equal to nothing. Okay. So, physics tick comes around. We pile up the delta. Then, if we're not currently updating them, we are going to set our current delta to accumulated, clear out the accumulated, and we're going to tell the thread loop to go again. Which, whenever we do this post, what that allows us to do is get past this. should be everything we need. Oh, no, wait. Not necessarily the best name for it, but okay. So as soon as it's ready, we prep all the variables. Then we start the thread. So at the moment, this doesn't do anything other than start the thread. We are still doing the physics tick update elsewhere. So now we go into our entity pool. Everywhere that's doing the creation is going through this currently. So we are going to do entity manager add entity. In theory, this will work. Okay. Oh. Okay, that's a breakdown in the collision handling. Let us constrain this a little bit. Game object. We are doing that. Oh, okay, that's gonna... It's our physics tick. We are not gonna call the updates here. Okay, no. We're not going to call that. Need to make sure that we don't duplicate that. Then in the game, we're just going to have one of the weapons here. Okay, so we're not getting our physics function actually called. Okay, there is nothing in entities. Oh. This is why there's nothing in entities. Add mutex. Dot lock. Unlock. Entities to add. Dot append. Entity. Okay, so we're still running into conflict here. This is with removal of entities. We need to make sure that we are properly cleaning them up in the areas. And this is actually where one of the improvements I want to make is that this is trouble. This part right here. We don't want to have to keep looking up. We don't want the entities to be bound to an array driven by this. If I add a shape to one of these areas, my goal is to never remove it. Because that makes it fragile, and we can make it less fragile. Gonna step away for just a moment. Be right back. Oop, wrong button. And I'm back. Let's see where the kitties are. See Sherbet laying in the play area. Mason is settling back in. Put the camera on Ember. Okay, so what I was mentioning, the collision zones here have a fragility to them. And that's that whenever I have a shape to add, whenever we put an entity in them, we are assigning the shape, we are putting that shape into the collection. What I would rather do is when an entity is added there, the collision zone gets a shape and hands it to it. The entity does not have a shape until it's in a zone. That way, what can happen is that the zone maintains its shapes. If any time... Hey there, Zocade. Welcome. Anytime an entity enters, it gets assigned either a new shape or the first available shape in there that is disabled. When an entity leaves, its shape is disabled and put into a collection of shapes that are available. And that is entirely by index. You know, shape 3 is disabled now. which should help. Okay, so we're gonna do a quick we're gonna do some source control here. That, and we'll take that. That is a commit. There. So we are adding the entity manager, we are stopping the collision zones from updating the entities, and we are disabling pooling. All of those. Okay. So let's look at collision zone. I'd like to get it to a stable state here. Each entity has a shape index. If instead we had a dictionary of entities, for their removal, because we know to get rid of an entity, so then we would have to disable the corresponding shape, and then put that shape number. It's okay. The performance now, pretty good actually. We're in the process of that, so let me show. It's going to break very quickly though. Yeah. So we should be able to maintain at pretty good performance given the number of objects that we're going to be dealing with here. But we need to get the collision zones playing nice now. And part of that is going to be when we initialize the entity that we don't mess with the shape then. So get into the entity. It's okay for it to have a shape index in it. Yeah. Area shape index is okay. It doesn't need a shape RID, and it doesn't need an area RID. we're doing now is we're removing we're gonna need to figure out how to set this. We are going to have a call to the entity to say to either get the rectangle for the entity or to get the dimensions for it. So either it's going to return a vector and say this is the scale of my rectangle. I think that's what we're going to do. All the shape calls. It's going to be another one that we need to make sure that we don't. This is going to be something that the collision zones do independently. Is they're going to look at their collection of entities. So, one of the things that we're going to be doing during this is creating kind of bridge objects. As far as the physics, the collision physics is concerned, the collision zones, it doesn't care about the core entity objects. That is actually separate, so their data structure is separate, where they are and how they move. That's all separate. The collision is one thing. Their rendering is going to be another thing. We're going to see if we need to mess with their rendering. Like how they draw. For now, we don't. But that's one thing that we can note is that whenever we need to do rendering processing, the only thing we care about is what sprite to use and like which animation frame. That way we can determine what to render and where. So a position, a facing, an animation frame, and a texture, those all give us what we need to do with rendering. Those have nothing to do with movement. As in, I can render without any knowledge of how it moves, as long as its end position and facing gets updated. And a flag to be whether it rotates or not. Camera 1 misbehaving. Camera 1 jamming. Okay. So we need something that is added to the collision zone that is not the actual entity. Yeah. So there is something that connects back to the entity and that the entity is connected to, which will be a bridging object. Navigation is something that we can leave here for now. we do this, this will remove collision. So let's see what happens. Okay, we have navigation movement from the blobs. We have the orbital motion from the mice. We are sitting at 1,000 blobs and about 250 to 300 mice. Steady 30 frames a second. Let's make that go bonkers. 6 mice, spawning 50 at once. Now you can see there is a bit of a lag in the physics, and we do have some hitches in physics now and again. Okay, at about 2700, we can do about 20 frames a second physics. Not perfect, and that's with, I think, just one motion. Yeah, it's just one motion. One thing we can do is not do the physics processing if it hasn't been long enough. It needs to be about 2/30ths of a second before we would consider doing another physics step. So let's add that in just to be sure. Constant. Oh, divided 30.0. Okay, so there has to be at least 1/30th of a second between physics updates. So our thread, then we go up into our physics tick. They're not updating entities, and accumulated delta is greater than or equal to minimum delta. Okay, notable improvement, notable improvement. Now this is without collision though, and we can see there's some wobbling with physics. There's some more stuff we need to decouple here. And we also need to fix some of the jitter on the blobs. Let's see, how are we having them move? Let's also... We're going to do a couple of tests here and verify is definitely where we want to be. gonna do 5 for it. Let's actually do the 10. And we're gonna go into the mouse and we're gonna remove the burst. Okay. We're doing a little bit of stress testing here. Okay, at about 3,500, we start to throttle off a little bit here. Let's double check when we move. If there's an agent RID and the called navigation avoid mask. Okay, this excises navigation from the mouse movement. It has thrown off the facing too, but okay, that didn't matter. Okay. So what we are seeing to some extent is stage 2 of the problem here. So we're spawning 50 of these, 300 of these things at a time. Eventually we hit a point where there's just so much going on. So if we tab back over, oh, well, we have a problem. Area remove shape. So we've got an error case here that we need to find. Here we go. have an area RID. If we have a shape RID. We have problem. Agent set position. This is probably... No, that shouldn't be a problem. Okay, entity agent cleanup is having problems. Yeah. How that is coming in null. Neighbors, distance. At this point, we've got to have one. So at this point, it should be gone. We should not have any other interactions with it. Put an assert here. Wish we could see more of the stack here. Let's remove navigation from the equation. Whole other element I want to deal with here. As such, because we've removed that, let's get the blobs out of here. Oh. Hello there, and welcome. Entity, let's move function. Okay, but we're not actually moving. Should be getting target movement out of this. Okay. Is self in this. It's the player entity. So we're gonna release that a little bit. Pause. This is a homing mouse. It should have a target movement, but it does not. Okay, so it's the homing mouse. We don't have a prior movement. We update the values we call move. No target movement. Not generating errors. Okay. We should have an adjusted velocity now. We do not. We should have a last direction as well. It's our turn angle. That was... is going on here? Delta is 0. That's what? No delta's getting in. But how is that possible? Delta. So then we go into our thread. Current delta. Delta is a thing. Delta's a thing. It should actually be impossible for delta to be 0 during this. It would imply they're just not moving. Okay, so this should be when they're getting created. Oh, ow. Ow, Ember. Ow. You can move along. Yeah, I know. Breaking down here. All right, so for those watching, what we're trying to figure out is why they've stopped moving. We've removed navigation from the equation here, but that doesn't mean that target movement should be any different. Zero delta. That's another optimization we need to make here. Hey there, Sayori. Welcome. Okay, so it's just not moving, is the thing. We're never coming around to it, which is weird. We're only ever calling entity move here. Oh. Okay. So previously, moving equals false. Alright, navigation has been removed from the equation. I'm gonna spawn a whole bunch of them at once. And about 3,000 objects without collision. We're holding at about 20 physics frames a second. No errors. What if more still? Alright, at about 6,000 things, it starts to throttle. Now, there's also the possibility that some of the rendering is going wrong. But 50 things at a time is also a bit rough on the system here. So we are getting hitches now and again. Now, some of that can be creation and deletion of things. Okay, there's still refinement to be done. Let's put navigation back. Well, no, navigation was showing some problems. We need to revisit. For science. So we need to revisit navigation. And we're still at a point where this isn't everything. Let's do... So this is going to be our stress scenario. Okay, it is loaded up. We are running. Go into our debugger, we go into our profiler. Want this to be percentage of a frame, but only self. Grab our script functions. Pause. Okay, so drawing the entities is costing us a decent amount of time. Collision Zone's physics tick is costing us some time, as is entity move. So these are more of the things that I want to job off here. If we look at this, yeah, almost the entirety of our frame time is being spent in physics, in the rest of it. So entity move is not happening in the same thread. That's where things get weird for us right now. Okay. So we have the basic structure now. We have everything moving now. We still need... Now we need to start looking at getting the collision back in, because of course that is a critical aspect. And to get the collision back in cleanly, we need to create a bridging object between the entity's data structure, so how it moves, and how it collides. Because the collision system is independent of how it actually moves. Right now, we don't have like move and bump into as a core structure. Once we get navigation back in, to some extent that will happen on its own for the blobs, which try not to step on each other. But as far as any player projectile, they don't care about where the other ones are for the time being. So we need to so we create that bridging object, and we change the collision zone so that it handles all of the shape logic. It creates the shapes, it assigns them to the bridging objects. So each entity keeps track of a bridging object and tells it, this is your position now. When that entity is done being moved, it tells it, this is your position. Then when the collision zone does its updates, it goes through and moves the appropriate shapes into their new positions. Yeah. That way, if the collision shape updating is falling behind the movement updating, or vice versa, they don't update until they get the latest information. That can mean there's some desync. It can mean that there's the possibility of missed collisions. But for the time being, that's what we're shooting for. If we get smooth physics updates, if we get that 30 frames a second, we should not be getting hitches in collision. So I'm going to step away for just a moment. I will be right back, folks. And we're back. So, again, kind of first stage optimization here, which is getting the movement threaded out. I don't want each collision zone to have its own thread. For the time being, let's leave the idea of collision physics within the actual physics tick thread. So that's the main thread. Which means we need to change the collision zones. And we need to have the entities handle that. Remove the handling of the shapes from the entities. So we're going to add an entity. Instead of adding an entity, we're going to add a bridging object. So let's go. Let me verify what we've changed so far. Okay. So here's where we get told that an entity should be removed, but we don't actually care about the entity getting removed. We care about the bridging object getting removed. So let's add that bridging object. We don't need a different enemy or item. Instead, we are going to create a new script, which is I'll do an entity shape. Also going to get one prepped, which is an entity visual. Okay, so the visual is going to be what we're going to pass along to something that will handle the rendering. If we get that far, one of the things that might happen is that we use something called a multi-mesh. Doing that would limit our ability to animate sprites individually. Cough. So if we have to use multi-mesh, we lose the ability to independently animate each entity, and instead everything that shares the same sprite would animate at the same time. Even color-shifted variants. It's a performance improvement. And that might be one of the areas that we save because entity draw is eating some time here. Why is physics tick taking so long here? What if... A 6,000... That was a big hitch there. Okay, you can also see the physics is going haywire at this point. Because we have those increasingly large deltas. Yeah. What if... Let's do a little update here. Hey there, Alex and Max. Welcome, welcome. We are gonna always use minimum delta. Let's try that. So instead of calling move with current delta, we're going to say minimum delta. Oh, thank you, Max. Thank you. I appreciate it. Okay, so even if we're slowed down because of processing, we are forcing it to always move at a rate of 1/30th of a second. So as the physics ticks get slower, essentially the world slows down. We would need to pass that along to everything. But at about 16,000 objects, we hit too much. Okay. We should have started our profiler. Okay, we'll get in here. We get in and we... into our debugger, we're going to start our profiler. Latch on to scripting functions here. Doing okay at the moment there, Alex. Doing okay at the moment. Okay, so now we're going to pause. Where are we spending our time? Distance squared 2 is actually chewing time. Filling the world map is chewing time. But move spiral is eating most of the time, with drawing in second. Yep. Yeah, we got back rolling yesterday. Let's look at of the entire frame here. Drawing is eating a lot of our frames per second. Yeah, move spiral is a savings. Entity draw is a big savings. Yeah, press start. That is Sammy. Let's see how many of the others we can spot. We should be able to see Ember as well. Then it's either Mason or Sherbet on the pillow. Can't quite tell. Yep. Yep, press start. We have 8 live cat cameras that we use. We try to keep as many of them on camera during the stream as we can, and we use this to find them. Yeah, we can see 3 of the 5. Okay, let's... We know that that's always minimum delta. That's always minimum delta. Delta minus equals minimum delta. Okay, so drawing is one of the things we need to deal with. No. But we're also never supposed to get to about 15,000 objects. So if we go in here, we pause. Oh, no, I didn't start the profiler. We're stress testing the system. Let's do that again. Let's verify where we're spending our time. Here, get over here, start the profiler. Mark scripting functions so it's easier to find. Press start. We're making a bullet heaven, so it's a game like Vampire Survivors is, where the player sprays bullets everywhere to try to hold off the enemies. And that's part of the reason that we're stress testing right now, is we want to make sure that we can handle as many as we can on screen. Yeah, that is what people started calling that genre when Vampire Survivors really kicked it off, or got people interested in it, is bullet heaven, meant to be a... yes, press start. It is the opposite of a bullet hell. Sometimes there's a little bit of overlap in them, but frankly, if you start to include bullet hell elements, then it's not really a bullet heaven anymore. Bullet heaven is really specifically when the player is the source of all of the projectiles on screen. Because personally, they don't mix at all. It's if you're having to dodge enemy projectiles, then you don't have the screen real estate or the visual bandwidth, essentially, to communicate both the player's projectile output and the enemy projectile output. It just becomes clutter, and if you minimize one or the other, it either makes the game difficult or it makes the makes the game, yes, needlessly difficult as opposed to challenging, or it means that you have to suppress. You either suppress the player bullets, and so the player doesn't get to look cool, or you suppress the enemy bullets, and the player gets killed. Hey there, Okaneki. Yeah, Undertale's combat system has more in common with a bullet hell. Okay, we go out, we pause. Where are we spending our time? Okay, draw is still a big draw. And then the spiral motion, yep. Okay, I think the next big victory then is going to be getting the drawing isolated. Hello, Mason. Mason will run over to the side of my chair and chirp at me if he wants attention. He likes belly scratches. He is my only cat that does. Yes. It'll be. I mean, it could be a really fast, quiet meow. Almost a squeak. But trills, meows, what I call a chirp. There's also kind of a chattering sound that they make if they see something that they would like to kill, usually. So sometimes if you watch a cat like looking out the window at like a bird or something like that, they'll make kind of like a chattering sound. Kind of a a hard sound, kind of like a K kind of sound, but really rapid. Sir, come here. There you go. It says I didn't want you to pick me up. That can happen a lot, Okaneki. It can be that the cat doesn't have um that the cat doesn't consider like their litter box sufficiently clean to use. It can also be a sign that they're having difficulty using the litter box, and it can also be a sign that they're mad at you, or that or that your laundry really stinks. Those are all common things as far as cats doing that to like laundry. Okay, so first win would be separating out the rendering logic. Because again, we don't need to paint too often, and not everything needs to be repainted, though it should be. Everything should be repainted when we do a repaint. At Press Start, I have 2 different streams on YouTube, and then I have a Twitch channel running the same stream as the wide view. I did not, Alex. Let's see. Of mine, I don't know the providence of Sherbet and Mason. They are shelter cats. Sammy is a feral though. She was a barn cat. But the rest of them are shelter cats. How are we going to do this, though? Hey there, press start. Welcome on the Twitch side. So let's see here. Oh, all my cats are indoors. I mean where I got them. None of my cats ever go outside. So one possibility would be to start shifting over to a multi-mesh. So our last change here was stress testing. This is a bit of a paradigm shift. So we've added a physics thread, like a custom physics thread. I think the next biggest win for improvement, we need to get the rendering out. So we need a visual bridge object, the entity visual here. And then we need a manager that is going to handle the visuals. So let's add that. We're going to call you the Mesh Manager. Okay. So how are we going to do this? We don't want it to be in the global entity. What we want to do is have I think we can still have the mesh be fully global. So let's change that. The mesh manager is going to have a script, which is going to be the mesh manager script, and then the project, it's auto load instead of that mesh manager there. We are going to open the scene, just so. I don't use the expressions a lot, but they're there. Can it extend a node 2D? Okay. Okay, so we need to create a multi-mesh instance for each texture that we're using. If we load the catalog first, then we can go through and find each texture and create a multi-mesh instance for it. So the pools we don't really need at the moment. We need all these factories and whatnot. Okay, catalog is loaded first. So then I think Mesh Manager insists on being a node 2D. A node. Oh, okay, it saved. And on... Why are you not giving me the default? Oh, it's not on ready, it's ready. Okay. Catalog, load textures. Okay, we're going to get each texture in the textures list. Okay. Sir. Mason demands back scratches. Texture is a texture 2D. In catalog textures. Currently do nothing. Choose 2D. How much am I in my Twitch? I stream to my Twitch at the same time that I stream to YouTube. I talk to it as much as people talk in it. I need to instantiate it. Okay, should be new. Let's go in and we're going to add a multi-meshed instance here just so I can see all the properties I need to mess with. Okay, it has its texture there. We're going to have a new multi-mesh. In that multi-mesh, we've got all the defaults, but we need to then set its mesh. Okay. Oh, I don't keep track of how many people are watching in each area. If somebody's there and wants to talk, I pay attention to them. If they're not, then I keep streaming as usual. It is the way. Okay, then this is a quad mesh. And its size. Wow. Hey there, Panzer. That is a long handle. Alex, it's something that I wanted to try, and I did, and it just kept happening. And child mesh instance. Wait. Dot values. Pause. Mesh manager. There we go. Okay. Hey there, Zane. Welcome. And yes, Panzer, that cat is Sammy. It's a good opportunity to check on the others. Okay, we can see 4 out of 5. We have Ember across from my keyboard. She's the little kind of gray, orange, and black striped. Sammy is the tuxedo that you could see earlier. And then Mason and Sherbet top to bottom on the pillows there. Okay, we can create the mesh manager now. So then entity visuals. Entity visuals will have... Oh, that's a pretty young kitten there, Zane. 6 weeks old. Have you decided a name? Visual does not extend a node. Okay, so we need a position to render it at. We need a facing. We need whether it flips or rotates. Charlie, huh? Nice. Okay, let's go in. Ah. These. This. Say variable texture as a texture 2D is equal to catalog textures. We'll just call this key. There we go. There we go. Then we create a new mesh instance. And we say meshes E is equal to mesh instance. All right, so now we have a texture key indexed dictionary of the mesh objects that we create. Do a quick check here. Yep, okay. See, we have a mesh instance with a name of the sprite that they have, with each one having the corresponding texture. So then Mesh Manager will also have an array of stop that for a moment. Entity visual has a class name. Visual. Default equals that. Okay, so it needs a position. It's not a node, so we're going to have okay, and it will pass itself in when it wants to be removed. Okay. So each time one is added, the visual manager will register the remove me. It will look at the texture key that is there. And it will add it. It will add it to its collection and it will render it in the appropriate mesh instance. So what'll happen with the mesh manager is it will iterate over the entities that it has, the entity visuals that it has, and it will then grab the relevant mesh for each of those visuals, and it will update. No, we want this to be cleaner than that. Yeah, okay. Okay, visuals is a dictionary. Okay, so each texture key will point to an array which will contain entity visuals. All of those entity visuals have the same one. So then when we are going to draw this node, we are going to iterate over all of its contents. And for each one, for each multi-mesh, we are going to go iterate over it and update the number each of those entities. Okay, so here is our default methods. Okay. We're going to try to do this once each frame. So okay, or key string in meshes dot keys. There's an array of entity visual is equal to visuals instance is a multi-mesh instance 2D is equal to. That the one we want to store off though? Okay, no, we want to store off the multi-mesh, not the mesh instance. So we don't do that. We do that here. meshes. So now we have a multi-mesh, and we have all of the entities that should be in it. Visible instance count is equal to entities dot size. This is how many of the instances indicated in it should be rendered. Then for visual so for each one of them, then we do mesh.set instance transform. We have to use 2D here. Yep. Transform 2D, so it's going to be entity visual dot position. Don't need to do this on separate lines, but we're gonna for readability. Facing dot angle. Oh, okay. I as int in visuals dot size. Visual as entity visuals is equal to visuals I. Okay. So every time we get a visual update, what we're going to do is we're going to iterate over every entity visual that we've got. So this is a bit of a process, but as part of that, what we're doing is going into each of these multi-mesh instances, and we are we are updating how many should be visible in it, and then for each of them saying this instance is located here. How do we flip? Don't think we can use translated is the thing. We don't want to multiply by -1 right away. So it should be translated to move it is the thing. Okay, no, that's scaled. I think it's -1, 0. I think it's that. Hello there, Nintendo. I think that's what we have to do. We'll get to that in a moment. Okay, so then each entity will need to interact with the mesh manager. Doing pretty well. Making headway. We're going to leave that. So we need to add to the mesh manager each time, which means we need add remove methods. We are working on we are making a game kind of like Vampire Survivors. We're currently working on a new rendering process for it so that we can try to further improve performance. Because we've got the actual movement tightened up, there's more we need to do there. We now need to get the rendering tightened up. Entity visual. E as a string, and it's going to return an array of entity visuals. Return is an array of entity visuals equal to nothing if visuals contains as key, then to return to visuals return. else. Okay, so we're going to return this array. If we have the key that we're looking for, we're actually going to change it to be whatever the key was. Otherwise, we're going to create that array. We're going to stuff the collection with that array and return it. We could avoid creating an array if we do that here, though. There. So we only create a new array if we get to here. Array of visual entities. Entity visuals. To append. I'm going to connect the signal here. If visuals dot find that I still have to do. As it, then we are going to erase it. We're going to connect the remove signal of this visual to do that. It's here. Visual. So when we are connecting the signal, if not visual, remove me is connected to on visual remove me. Then visual.remove me connect to on visual remove me. Same thing, but it's going to be disconnect. If it's connected to that, then we're going to disconnect it. So if we add it, we now connect to it. We remove it, then we are going to disconnect. Okay. We get the disconnect signal we call remove on. So now we can add visuals and we can remove visuals. Remove is going to actually be an internal function. Okay, so it loads up all of the meshes that it needs, and now we can add visuals to it. So in an entity, oof, there's a lot going on here. We have visual elements. We have an icon, which is for the UI. This is going to be another element that we split off, but so it will contain the texture, the color modulation, information about the frame, and whether it flips or not. And it can also have a visibility flag to it. But I think we are going to want to skip an entity if it doesn't have, if it's not visible. We'll get to that later, though. It doesn't rotate, it flips. Color. I'd like to keep it uniform as far as how big the entities are. Okay, so mesh dot set instance color equal to that. Position, its color. We'll have to figure out how to get the transform proper there. Sets its color. Okay. I think we need to go over this twice, though, which I don't like, but what are we going to do? Variable to render visible visuals. Is that? If visual visible Okay, so what we're doing is we make a first pass of the visuals that we've got in that one, and we accumulate all of them that have visible set true. This is going to be determined. We can make an extra determination here as to whether it's visible or not based on, like, is it on screen? If it's not, then what we'll do is not include it in the collection. Then we'll iterate over that collection and update it. So we have a number of instances equal to the size of the visible ones, and we iterate over those. Get visual array. Okay. Still running, not broken. We'll need a flag to update these, but same way as we'll need a flag to clear this, essentially. It's kind of a TBD here. Okay, so we've greatly improved the pace at which we handle the physics, and we're on our way to improving the pace at which we can draw objects. Yeah, I think this will be our stopping point for the night before we get too much further into the weeds here. Yeah, I think we've had a pretty good run tonight. Let me set up a couple of things. What'd you folks think? We're up to like a solid 5,000, I think. Solid 5,000. Do that. There, and just pushing some buttons here real quick. But yeah. So next time we do our coding, we will be working still more on the visual aspect. We're going to get that multi-mesh thing up and running. So instead of using individual canvas rendering, we're going to have the multi-mesh do it. There might be ways to make the canvas rendering cleaner, but this way should reduce it down to one object handling all of it for each texture. So ideally we'll be pretty good there. Hello, Sandwich, popping in right at the end with us here. Let's see. But yeah. Let's do... Let's actually do one more showing of where we are. So we can see our rendering frames per second is holding pretty steady, but it's about 4,000 things that we start to get hitches as they appear. This is way more than we were able to render before. But we start to get issues drawing them as we go along. But yeah. We're gonna see about... So it's either going to be early next week or tomorrow that we'll do more coding. I will post the next stream is tomorrow morning-ish to see what we do. It'll either be some more gaming, maybe some puzzles, continue on with a little to the left, or it'll be more coding. Trying to make sure that we don't get too far into burnout territory on the coding, because we're doing some pretty intensive stuff now, and we're having to make some pretty substantial changes to the code base. So I've got to be careful, but also I want to move steady. But I hope you liked. I hope you had a good time tonight. If you like what you see and would like to see more, remember to like, follow, subscribe, that kind of thing. It helps the channel grow and will help you find the content more easily in the future. With that said, I hope the rest of your evening is a good one, and I'll see you next time.